Good morning, afternoon, or evening, wherever and whenever you are. My name is Benjamin, and welcome to this Godot 4 Action RPG YouTube series. Before we jump into this series, I want to show you the project we're going to be making. I've got it up right here. We're going to be covering topics like moving a character with input, building a world with scenes and tile sets, creating complex behaviors and animations with state machines, melee combat using hitboxes and hurtboxes, and enemy pathfinding using navigation meshes. I will be covering those topics within the context of an actual project, not just one-off, and so you'll be able to see how they all connect together in order to make a cohesive experience for the player. You might be excited to jump right in, but first I want to make sure that you are a good student, a good fit for this series. This series is not for students who are brand new to programming. If you've never programmed before, if you don't know what a variable is, if you don't know what a function is, if you don't know what a class is, if you don't know what a for loop is or an if statement, then this series is not for you. However, if you're brand new to the Godot game engine, if you've never used Godot before, you should be okay, as long as you have some basic programming experience. If you've used Godot before, or maybe you're a little bit of an intermediate user, you still might find some value in a few of the topics that are covered. If you've made it this far in the video, I want you to pause the video right now and go to godotengine.org and download the latest version of Godot. I will be starting off using Godot 4.4.1. However, this series should work just fine with any 4.x version. If it's Godot 5, if Godot 5 is out, then all bets are off, but you should be good with any 4.x version. There's also going to be a link in the description and in the pinned comment with the resources that you will need for this project. So again, pause the video, download the latest version of Godot, and go download those resources, and then you should be good to follow along. You're going to get the most value from this series if you commit to following along. If you just watch the videos and don't do the actions yourself, you're just not going to learn as much, and I highly recommend following along because you're going to get the most value that way. Once you've downloaded Godot and the resources, you can open up Godot and you'll be presented with the project manager window. Here, I've got a bunch of projects. You're not going to see any, but that's okay. You can just come over here to this create button, and I'm going to browse to select a folder. I want to save this inside of Godot 4 tutorials. Select current folder, and I'm going to call this YouTube Action RPG, and I'm going to create this new project. When we create it, Godot will open it up, and we're presented with this window here. Over on the left, we have the Scene tab. This is where we can edit the scenes that we have in our project. A scene is just like a collection of nodes, and nodes are kind of like the base fundamental building blocks of the game. So you combine nodes in interesting ways to create new scenes. And then over down here, we have the file system, where we'll have the different resources that our project will use. In the middle here, we just have the game view. And right here on the right, we have the inspector. This will give contextual information about whichever node or resource we have selected over here on the left. We can start by creating our very first scene. Just click 2D scene right here and it will create a new scene. I'm going to double click on that, or you can hit F2 as well. And we'll name this world. I'm just going to hit Control S to save this scene. Save it, and then we can press this run button to run the game. It wants us to choose a main scene, which is just the scene that is run very first whenever you run the game. We'll just select current, that will be our world, and here we go. We have a game that is running. It's time to import in our resources, so I'm going to select all of these folders right here inside of the YouTube Action RPG resources and drag and drop them over here into our file system. When we do that, Godot will automatically import them into our game. Now there's a few problems. Let's start by clicking on World and grabbing this bush and dragging it over. And you can see the first problem is it's very tiny. And the next problem is that the pixel art is kind of blurry. Now to navigate this window, you can middle mouse click to pan and then scroll wheel to zoom in and out. So let's solve those problems that we have with the blurry pixel art and the screen that is too big. Come into Project, Project Settings, and go to Window, and then set the viewport width to 320 and the viewport height to 180. Now this is a 16:9 aspect ratio. If you scroll here, you can see that gives us, if you can barely see these blue lines here, it gives us a window that is more appropriately sized for our pixel art. Now come back into the project settings, and up in this filter right here, just type filter, ironically, and click on the texture, rendering textures, and then default texture filter. We'll want to set this to nearest, which is the best filter for pixel art. Now if we run our game, we can see that our window is small and the pixel art is not blurry. The problem is we want to actually scale this window up so that it is appropriately sized on our screen. On my monitor, this is very small. So we'll go to Project Settings again, and close out of that, go back into Window, and we have this window width override and window height override. Now you may need to make sure that advanced settings are on, so make sure that that's on. We'll set the window width override to 1280 and the window height override to 720. And then we have to choose how it's actually going to scale up to that override. So the stretch and then stretch mode here is where we select this. You see it's currently disabled. We have two options. We have canvas items and viewport. If you're a pixel purist, you'll probably want viewport because that will only use the 320 by 180 pixels that are available. If we use canvas items, it will allow us to use more. I'm going to choose canvas items. Pixel art purists might get mad at me. If you want an example of a game that uses canvas item like scaling but still does a really good job of it, you can check out Crosscode on Steam. And so canvas items is fine. But if you are a pixel art purist, I'm going to tell you how to do it. It is viewport. That is what you want. Now we're going to delete our bush here. I'm going to select the node and just press delete like that. And we're actually going to create a new scene for our player character. We can do that by pressing this plus button here. That will create a new scene. Now our player character, while they are going to be a 2D character, we don't actually want to hit 2D scene this time because we're going to be using a specific node that has some behavior and some functionality that we want for our character. So click other node and do character body 2D. And then we'll name this player. And we can save this, and we can save it in the players folder, just like that. Why are we choosing a character body 2D? Character body 2D allows us to move a character around in a space. Godot will automatically handle the collisions of that character, but we maintain control over the movement through manipulation of a velocity property on the node. So unlike a physics object, which would just use Godot's built-in physics, and we wouldn't have direct control over that object's movement, the character body 2D allows us to maintain that direct control. It's ideal for platformer projects and action RPG projects like this. It would be perfect for our character. However, by default, the motion mode on the character body 2D is set to grounded, which is for platform characters. We want to switch this to floating. Now, I know that might sound a little counterintuitive, but floating is actually the correct motion mode for a top-down action RPG. Because if you imagine, they are kind of floating around in the world. They're not actually touching walls and stuff, and they're not falling down. And so they're kind of floating in the world. But that's the one we want. Once we've created this new player scene, we need to add some more nodes to it in order to correctly display it and have it collide with stuff. We'll start with display. If we click on our player root node and we click this plus button, we can add a new node, and we're going to search for sprite 2D, just like that. And now we have this sprite 2D node, and when it's selected, we have a texture property over here. If we come into our player folder, We have a player.png resource. We can drag this into our texture property. Now this has all the animation frames, and there are a lot. But if we come to our animation tab and we set the horizontal frames to 60, which happens to be the exact amount of animation frames there are, now we have a sprite that is correctly displaying our character on our scene, and we can save this. If we come back to our world scene, we can now come down to the file system and drag this player and drop them into the world. And what that does is it actually instances our player scene inside of the world. So this player right here is actually an instance of this player scene. You can see it doesn't show the sprite 2D. It doesn't need to. It just shows the scene itself. And then we get this little icon that allows us to actually click on this and open up that scene in the editor. Pretty cool. So you can put scenes within other scenes. So a scene is constructed of nodes and also potentially other scenes. It's a very powerful system. Now if we run the game, we can see our player character right there. We'll come back to our player character scene. Make sure you come back to this tab. We're going to add a script. So press this little plus button for a script. And the template, it might try to do basic movement. We actually want to do just do empty, and it should inherit character body 2D, and it should name it player.gd. That's the script, and it should be in the player folder. Create that. I'm going to press these to kind of hide these tabs here. You can see our script extends character body 2D. That is because it is attached to a character body 2D node. Now we need to make a constant up here, and we'll call this speed, and we'll set this equal to 100. That will be the speed of our character. Now we need to create a function here called physics process. The physics process is called every single physics frame, and we can use this function in every single frame, every single tick of the physics process in order to move our character. So we could do something like velocity equals vector2.right times speed. Now we've set the velocity, but we actually have to update the position of the character with that velocity using move and slide. And this is a function that is associated with character body 2D. Now we need to learn about the documentation. I know, you don't want to learn about documentation. Most people, they hear that word and they don't like it. But Godot is actually really easy to use. It's easy to access the documentation if you hold Control and then hover over these functions or nodes, or not nodes, properties. We can easily open them up in the documentation. For example, some of the experienced programmers out there might be wondering why I didn't multiply this by delta. Well, if you hold Control and select velocity, it will open up the velocity in the documentation, and you can see that the velocity property is the current velocity vector in pixels per second, which means the velocity is already time dependent. It's not frame dependent. So Godot is already handling it, multiplying it by delta under the hood, so we don't have to multiply it by delta. You can also see that it's used and modified during calls to move and slide. And if we click on move and slide, we can see that this is how a character body 2D is moved around according to the velocity property. Now if we save and run the game, our character is going to move to the right with a speed of 100 automatically. That's cool. Now we want to get some input from the user. So first what we'll do is we'll just set our velocity equal to, we'll set our velocity equal to vector2.0. So by default, we'll just set it to 0. But then we can get some input from the user, and we can do this using the input global class. If input.isAction pressed, we're going to get a list of actions here, and these are the default built-in actions. For now, we'll use UI write, but later we're going to be setting up our own actions because we don't want to use these default actions. They're reserved generally for UI, but this will correlate to the right arrow key on our keyboard, so we can use it to test this. Velocity.x equals speed. So on an xy coordinate system, right, x positive is going to be to the right, and x negative is going to be to the left. So we can also add in if input.is action pressed UI left, and we'll say velocity.x equals negative speed. Now we're going to the left. Now let's do up and down. If input dot is action pressed UI up, velocity dot y equals, and here's where you're going to maybe be surprised, negative speed. Now that's because in 2D games, in most game engines, the top left corner of the screen is 0, 0, and down is positive, and up is negative on the Y. So they're flipped from what you might expect. Input.is action pressed UI up or down. And I'm sure you could do this on your own at this point. Velocity.y equals speed. Saw where that was going. Okay. So by default, we set the velocity to 0, but then if we're pressing any of these arrow keys, we're going to manipulate the x or y value of the velocity, and then move and slide will still move our character. We can move our character around on the screen, just like this. Now, one problem with this is that up and to the right, or any diagonal, actually moves faster. Let's take a look at why. Got a little drawing program opened up right here. If I draw an xy coordinate system like this is our x, negative x, this is positive x, this is positive y, this is negative y. Done any geometry, this is going to look very familiar to you. Now imagine that we want to move 2 ticks in this direction and 2 ticks in this direction. That gives us a point of right here, and the value of this point would be x2 and y2, right? That makes sense. Now we can draw a line to that point, right? What is the length of this line? Well, we all know you'd have to use Pythagorean theorem to derive, to figure out the length of this line. But what we do know for sure is that this line is longer than 2. And that's why we're moving faster at the diagonals. Because if our character is moving 100 in this direction and 100 in this direction, those two vectors combined together creates this longer line, this longer direction. And so that's a problem. Also, the way we're getting input here is kind of annoying. We have to do every single individual direction. It would be nice if there were a way to get all of those directions at once and just output this completed arrow, right? Because we're kind of constructing an arrow by doing 100 in this way and 100 in this way, and it constructs this arrow. Or maybe it's 100 in this way and 100 in this way, and it constructs an arrow like this, right? It would be nice if we could just get this arrow from all of our action keys automatically. And good news, there is a way to do that. If we come back to our code here, we can actually just delete all of this. And what we can say is var input vector. So we're going to, that line that we created by adding to the x and y coordinate of our velocity was a vector. Whenever you have a combination of an x value and a y value in a single unit, it is called a vector. So we're going to generate a vector from our input actions. So we'll say input vector equals input.get vector. And it wants a negative x input action, a positive x, a negative y, and a positive y. So we'll do UI left for negative x, UI right for positive x, UI up again for negative y, UI down for positive y. And this is going to generate a vector, and we can actually print this vector real quick, input vector, and see what value it is. Our character won't move, mind, but as I'm pressing the arrow keys, we're printing this vector, and you can see it's an X and a Y. If I press just to the right, we get 1 in the X and 0 in the Y. If I press just to the left, we get -1 in the left and 0 to the Y. Okay? And then again, if I'm pressing multiple, we get a generated arrow. Now, the problem with our old system, right, moving faster at the diagonals, is that whenever we added these two together, we got a longer version, right? But the great thing about this getInput function, or this input.getVector function, is that it is normalized. Now, when you normalize a vector, what that means is it draws a circle with a radius of 1, and it chops the vector off right here, making no matter which way the vector is pointing, the length of it will always be 1. Okay, that's what normalizing a vector means. And we can manually normalize vectors, but this getInput vector, this getVector function on our input automatically normalizes this vector. You can see if we press up and to the right, we get a normalized value. We get X is 0.70 and Y is -0.70, and the length of this vector is going to be 1. So our input vector is always going to be output as 1. Or I should say the length is always going to be 1. And so what we can do is we can take our velocity and we can multiply it by this input vector. But that's going to be really slow because, again, the length is only 1. So our character is only moving 1 unit at a time, and that's really slow. But since it is 1, the length, no matter which direction, we can now multiply it by our speed as well, just like this. And again, remember from earlier that we don't actually need to multiply by delta because velocity is already time dependent and not frame dependent. Now, once we do this, we can move our character. Oops. I forgot. What we want to set is velocity is equal to input vector times speed. We don't want to just multiply it. That doesn't make any sense, what I did there. Velocity equals input vector times speed. And now our character will move around, but they no longer move faster at the diagonals. They still move the same speed because the length is always the same. And that's pretty cool. In a matter of minutes, you've created a project, imported in some sprites, and got a moving character around on the screen. That's all we're going to cover in this video. Thank you so much for watching it. I hope you enjoyed it. Please like and subscribe to the channel. If you want to support my channel and support this free content that I put out for everyone, please consider purchasing my Godot courses. I have a course on my website. There will be a link in the description if you're interested in that. Thank you so much. I will see you all in the next video.